Now we really start getting into advanced pointers. We start to examine the similarities and differences between pointers and arrays. If you recall, I actually mentioned to you earlier on in the course that there is a great similarity between pointers and arrays. Let's have a look at exactly the extent of that similarity. First of all, you need to know that the value of an array, if you can say that an array has a value when you use it in an expression, the value can be said to be the address of its first element. Now, compare that with a pointer. What does a pointer store? If you think of a pointer as an array of data, a pointer is really an address. We all know that a pointer is an address. So what is it an address of if it's storing an array? Well, you can think of it as the address of the first element of the array, which is exactly what the value of an array is. So they're very, very similar here. Now let's have a look at that in a bit more detail. It is actually legal to write the following. Now, you've probably seen this before. If you have 40 integers in an array and a pointer to an integer, you can simply assign the pointer to point to the array. The reason that can happen is because the value of the expression array on the last line there is simply the address of its first element. So the address of the first element of array is put into pointer. Similarly, you can pass arrays into functions that take pointer parameters, and vice versa. Although you can't really take an array as a parameter, you can only take an array that has no size. Anyway, let's move on. They're very similar. Let's look now at the differences. They are virtually the same. You can use them almost interchangeably throughout the code. However, there's some problems with this because a lot of programmers who don't know any better think that they are exactly the same, and they make some mistakes. You have to know what the differences are. Here are the differences. There are 4 of them, and they're small. The memory used by an array is always set aside by the compiler. It's either in the stack or it's in a static memory area. Doesn't matter where it is, it will be set aside by the compiler. Contrast that with pointers. Pointers need to be initialized to point to something. They need to be able to be set to point to an existing area of memory, or you need to go and allocate some memory from the heap for them to point to. So that's probably the biggest cause of errors, is that programmers forget that a pointer needs to be initialized to actually point to a valid piece of memory. Arrays do not need to be initialized in the sense that they always refer to a valid piece of memory. If you take size of pointer, what you're always doing is you're taking the size of a memory address. The size of an actual pointer is always 4, is always the size of an integer. On a 32-bit machine that's going to be 4. On a 16-bit machine that's going to be 2. Contrast that with the size of an array, which equals however big the array is, however many elements there are in the array, multiplied by the size of each element. So if there were 100 integers, you would have an array size of 400. Doesn't matter how big the thing that pointer points to is, the size of the pointer itself is always 4. People confuse them very, very often. Next, the compiler will actually complain to you if you try to do this, but you can't put an array variable on the left-hand side of an equals sign, or something similar. If you did that, the compiler would assume that you were trying to change the value of an array, or in other words, change the address of an array, and that can't possibly happen. The address of an array is fixed. Anyway, the compiler will not let you do that, so that one's pretty straightforward. And finally, this one's kind of curious. If a variable called r is an array, then the address of r still equals r. In other words, those two expressions, the address of r and r, are both evaluate to exactly the same thing, which seems a bit odd, but we'll explain that further in the next module, which is on pointers to pointers. Now, you're looking at 4 differences. You might think, well, that's actually quite a lot of differences. Surely they're more different than they are similar, but no, they're actually more similar than they are different. I'll show you now all the similarities between pointers and arrays. Let's have a look at those. Let's say we've got the following declarations. We've got a function that takes, we've called it func, which takes a pointer to an integer and its second parameter is thought of as an array of integers. Notice there's no size in the array there. That's not legal to put a size inside the y brackets there. Now, separate to that, inside another function, you've got two variables, one called a for array, which is say 40 integers, and you've got p for pointer, which is a pointer to an integer. All the following statements are valid. Every single one of these will work fine. P equals a. You can assign p to point to a. What you cannot do is assign a to p. You can't reverse that because the address of an array is fixed. However, p to a works fine. You can assign the first element of the array to the first element of the pointer, assuming that pointer is set to point to something valid. In other words, assuming p, the pointer, has been initialized. You can use, what I'm really trying to show you here is you can use square brackets after a p. In other words, you can treat p as if it were an array. Similarly, you can treat the a variable, in other words the array, as if it were a pointer, and use the asterisk to take the contents of it. That works as well. If you don't believe me, try it. And again, it'll work the other way around. So it doesn't matter which side of the equal sign the star a is sitting on, because we're not trying to change the value of the array, we're trying to change the value of the first element of the array, which is actually legal. You can pass a and p into the function. Now, a is being passed into the first element, and p is being passed into the second element. And the compiler will not complain about that. And of course you can do PA, which is probably the correct or the way that you would expect it to work. All of those things work. In other words, once you've got an array and a pointer declared and the pointer is initialized, you can use arrays and pointers completely interchangeably. That's what that means. That's what this slide is telling you. Once the pointer has been initialized to point to a valid piece of memory, you can use them entirely interchangeably, keeping in mind obviously that that the size of a pointer is different to the size of the array, and you can't put the expression a on the left hand side of an equal sign by itself. Now that's all there is to it in this module. Given that all those examples of code at the end of the slide compile, I don't think we need to see any further examples on those. So let's move on to the next module.